Hi grade 7s. This is lesson 1.5 and it's about patterns, relationships, and tables. The learning target or learning goal for this lesson is you will be able to create a table of values for a linear relation by evaluating the relation for different variable values. So what's a linear relation, you're asking? This thing right here that I mentioned in the learning target. For our purposes, it'll be as simple as an expression, an algebraic expression, where we have a variable n, a constant term plus 3, and a numerical coefficient in 2. That was in the last lesson. So this will be our linear relation, and we're going to create a table of values from that by evaluating the relation for different variable values. So let's go back to grade 6 when we had the input-output machine. And we're simply going to have our input over here and our output. We're simply just going to plug in a value for n, and 2n plus 3, and create our table of values. So we can have input here, output, and the input of course is n, and the output is always going to be 2n plus 3. Well, let's make some input numbers, 3, 4, 5. Let's begin with 1. Okay. When n equals 1, we have 2n plus 3. We're going to put 2, there's the 1, plus 3, 2 plus 3. We have 5. We put that over. Erase all that. Well, for the second output, we have n equals 2. So back to our relation, our linear relation, 2n plus 3, we'll plug 2n plus 3, we have 4 plus 3, we have 7. Okay. Now, for when n equals 3, we will have 2n plus 3, 2, 3 in brackets, plus 3, we have 6 plus 3, 6 plus 3, we get 9. We put 9 over there. If we evaluate it for each of those, and you will show all your work and do the work for each variable or input number, you'd see our table of values. We have an output for every one of those inputs. 5, 7, 9, 11, 13. Now you also might be presented with a table such as the one I've got here, and you might ask to write the relation. What is the relationship represented by the table? So essentially what they're asking is, how do you get from the input to the output? Well, we can let any input number be represented by the letter n. So let's put n down here. Now we notice that the output increases by 3 each time. When the output increases by 3 each time, we know that in this case the input is multiplied by 3. So we can start with 3n. Then I can go back and I can substitute those original input numbers into my 3n. So I got 3, 1, 3 times 2, 3 times 3, 3 times 4, I'm simply substituting the input values in our original table into what we found with 3n. 6, 9, 12. So if we put those up here, 3, 6, 9, 12, and compared them with the output numbers from the original, we'll find that they're each less, we're dropping down by 1 each time. So therefore, a relation is 3n minus 1. Yep, let me tell you, there's a lot of practice and struggling involved here to figure some of these tables out. I hope you're up for the challenge. Good luck.